Hello, this is Mr. Waters, and here's another video lesson for you. And this has got to do with volumes of some other solid shapes, and specifically two that we're going to work on here: rectangular pyramids and cylinders. Now, what are they? Well, a cylinder is a relatively, common shape, like a tin can or a coffee mug, right, or a soda can. Those are all cylinders. We see a lot of them around, and we're going to work, and it's a common problem to be able to find the volumes of cylinders, so we're going to work on that. Okay, rectangular pyramid, on the other hand, well, they're also relatively common shapes. Okay, a pyramid, first off, technically is a shape with any kind of a shape with a flat base that's some kind of a polygon, like a square or a triangle or a rectangle or something, right? And with triangular sides that come up from that flat base and reach a peak and make a point at the top. So pyramids have got some kind of a flat base and triangular sides that meet in a point. So the kind that we're going to be interested in is this kind right here, which is the rectangular pyramid. Okay, meaning that the base is a rectangle. Right? And the sides are still, the base is some kind of a rectangle. Okay, now but there are other kinds of pyramids. For example, this one is a triangular pyramid, where the base, instead of the flat base, instead of being some kind of a rectangle here, is actually a triangle. But the sides that come off of that flat base are still triangles themselves, and they come up together in a point. Okay, anyway, this is the kind that we're going to be getting the volume of today. And remember, what we mean by volume is, okay, let's not forget that, it's simply the idea of how many squares, or how many of these volume squares, can we stack up inside. How many can we stack up to fill the space inside the pyramid, and how many could we stack up to fill up the space inside the cylinder. Okay? All right. So now it turns out that, here we go. It turns out that, and I'm going to cover up some of this so we don't see all of it at one time here. Okay? It turns out that here's our rectangular pyramid. Okay? The base is a rectangle, a length and a width, right? And then it's got a height that's measured from the base, that is whatever that flat base is, the rectangle base, up to the top of the point, right? Now it turns out, now how do we find the volume of that? Well, remember when we found the volume the area of a triangle, first we started with a rectangle that had an area of base times height, right? And then we took and we drew a diagonal there, and that divided that rectangle in two. And this triangle here had an area that was 1/2 of whatever the corresponding area of the rectangle was. So we multiply base times height to get the rectangle, then we divide by 2. Okay, so that's where our area formula for a triangle came from. Base times height divided by 2. Same kind of thing, as it turns out, although I can't prove it to you here, the same kind of thing is true about pyramids as well. If we start with this rectangular pyramid, it turns out, you can see here, I've drawn it in red, that pyramid is can actually be set up inside of a box, a rectangular box, like we found the volume of last time, right? And that box had a length and a width, and then also a height as well. And we could find the volume of that box by multiplying length times width times height. Well, in the same way that or in a similar way that a triangle is half of this rectangle, it turns out that this pyramid is exactly 1/3 of the volume of this box that it's sitting inside of. In other words, if you could kind of cut it up a little bit, you could fit 3 of these pyramid volumes inside of this rectangular box. So what do we do to find the volume of the pyramid? We multiply length times width times height to get the volume of the box, but then we divide by 3 to get just the pyramid. For the same reason we divided by 2 to get the area of the triangle, we're going to divide by 3 to get just the area of the pyramid that's inside the box. Okay? All right. So that is our volume formula for pyramids. Length times width, which is the length times the width of this rectangular base, times the height, which is the distance from the base up to the top of the point. So, for instance, here's a famous pyramid. It's a pyramid at Cheops in Egypt. And as it turns out, it's a rectangular pyramid, but a special kind. It's actually a square pyramid where the length and the width of the base are actually equal to each other. In this case, they're both 230 meters. And the height, as you can see in the picture here, maybe not, maybe you can if you zoom in, is 147 meters high. So let's find the volume of that. Now, before we do that, you can see, one of the reasons why I showed you this pyramid picture here, this Egyptian pyramid picture, is you can see that this pyramid is actually made up of just blocks stacked together, right? And most of it is just a solid chunk of blocks stacked together in the same way that we might stack up these volume cubes, right? And you could count up the volume of this pyramid by counting how many blocks are in that stack, right? Well, that's kind of the hard way to do it, but you could. And that, by the way, doesn't include the little bit of hollow volume, the hollowed out spaces that are inside the pyramid, which is, as it turns out, not a very big percentage of the entire volume. But in any case, to find the volume of this, right, we'd multiply 230, one width, times 230, well, the length, and then times 147, the height, and then so 230 times 147, that's 7, I did this on Mr. Calculator, 7,776,300, but then we divided by 3. Just like we have to divide by 2 for triangles, we have to divide by 3 for pyramids, and that gives us 2,592,100 cubic meters, right? Volume, just like area is always in square units, volume is always in cubic units, because really we're multiplying 230 meters times 230 meters times 147 meters, meters times meters times meters, meters to the third power. Okay? All right. So now let's see. I'm going to put this over here. Now what I want you guys to do is we're going to do another couple here, just like this. Okay? I guess that's good enough. All right. Slide that down so you can see the whole thing. Here's another pyramid with a base, a rectangular pyramid with a base 100 times 200 and with a height of 75, right? Well, how do we find the volume? 100 times 200 times 75, which is about 1,500,000. And then we divide by 3. Always divide by 3 for pyramids. And that gives us 500,000 cubic feet. Cubic because it's volume, and feet because that's the units that we measure. Okay? So anyway, this is our volume formula again for a pyramid. Any kind of rectangular pyramid. Length times width times height divided by 3. Okay, now what I want you guys to do is I want you to try a couple. Okay, now using this picture here, what if the length is 25 meters and the width is 32 and the height is 17, and the length is 6, and so that's kind of like try these, examples, or try these on your own, number one. And then number two here, what if the other one, another one, the length is 6.5 and the width is 1.7 and the height is 2. And the height is 2.1. Okay, so these are two different examples. Try both of them. Okay, and in a minute here, so hit pause on the video so it stops. Okay, and then while the video is paused, try those problems out, and then when you're done, come back and we'll go over the answers. Okay. Okay, you're back, I guess. Well, here's what we got. The first one is we multiplied 25 times 32 times 17, and that gave us 13,600. Then we divided by 3 for a total of 4,033.3 cubic meters, because the units I gave you are meters. Here, these units were inches, so we multiplied 6.5 times 1.7 times 2.1, right? And then they all multiplied to give us 23.205, and then we divided that by 3, and then gave us 7.735 cubic inches. That's the volume of that pyramid. Okay? So in a couple of minutes, in a few minutes, you're going to be able to see some classwork on this. All right, so now, what's the other part here? The other part has to do with cylinders and, well, cylinders. Okay, a cylinder is a shape like a tin can here that's got a circle on the top and a circle on the bottom that are flat with straight sides, right? And this cylinder, the circle on the top and the bottom are the same size and the same shape, so they both have a radius of r, and they both have a height. And it turns out that we can get the volume of this. Again, we're going to count how many of these volume cubes can we stack inside. Turns out we can count up that stack by multiplying pi, which is still, for us, 3.14 times the radius times the radius times the height. Now you might recognize this if you look at it closely. It's the area of the circular base times the height. Okay? So let's say we want to find the volume of this tin can here. Well, the radius is 1.5 and the height is 4. Measured it myself. So that means the volume is going to be 3.14 times 1.5 times 1.5 times 4. Then on Mr. Calculator, okay, 3.14 times 1.5 times 1.5 times 4 is equal to 28.26 cubic inches, because volume is always cubic units, and the can was measured in inches. All right, so let's try another couple of those. All right, so let's say we've got this one like this. Okay, here's the can, and remember our volume formula for a cylinder. Okay, cylinder is pi times radius squared times height, where this is the height from top to bottom and the radius is the radius of the circular top or the circular bottom. Either one will do. So let's say for this one the height is 10 and the radius is 5 inches, right? So the volume is 3.14 times 5 times 5 times 10. Now that's just calculator work. 3.14 times 5 times 5 times 10 is 700, as it says there, 785. So that's 785 cubic inches. Okay? Now you can look that over, you can rewind, but I want to do now is give you a couple to try out. Okay? Remember, that's our volume formula. And let's say we've got, draw you another pretty picture here. Here's our cylinder, right? And it's the radius and the height. And let's say that we've got one cylinder, and then pi is still always going to be, for us, 3.14. Let's say the radius is equal to 3 feet, and the height is equal to 7 feet. So try that one out. Calculate what the volume would be. And then how about one, and this is, by the way, is going to be example, or you try example number 3. This one will be number 4. Let's say the radius is 1.75 centimeters, and let's say the height is equal to 3.2 centimeters. Okay? Again, so now you're going to hit pause, and you're going to work on your own, try out to find those volumes of those two cylinders, okay? And then when you're done, start the video up again, and you can check your work. Okay, so those are your answers there. Okay, the first one I made a mistake. I forgot to multiply by 3 twice here, but the radius is 3 and the height is 7, so the volume is going to be 3.14, that's pi, times 3 times 3 times 7, works out to be 197.82, times 3, because it's radius squared, remember. On this guy here, the volume is 3.14 times 1.75 times 1.75. That's radius squared times 3.2. The height, it works out to be 30.772 cubic centimeters. Okay? All right, so that's how that works for pyramids and cylinders. Okay? So on Wednesday, what we're going to do is, like I mentioned in the other video, we're going to have a morning video conference. I want to talk to you guys about your tests and what we can, and then test corrections. And then you can also ask questions about this before you turn your homework in. Okay? All right. So I'm also going to post. You should see by now the video, the previous video in the classwork posted. I'm going to post this video and then this classwork, and also some homework that have got all the kinds of volume that we've done on it. Okay? All righty. Talk to you Wednesday.